Well, I am very honored to be able to have this opportunity to speak with you today. I don't know where Rich Baldwin is, but he's right in front. He didn't tell me that I'd be following an Olympic gold medalist. That is so not fair. We'll make it fun, but I will get you back for this. So we're going to go from killer Olympic performances that deliver gold medals to talking about NAND and DRAM. That's I will do my best to try to keep it interesting. In fact, with that, I'm going to start with a video, if I can operate this.
At Bloomberg, we have over 325,000 customers participating in the capital market, and our job is to help them understand kind of the flow of information. There are over 100 billion ticks of market data every day that flow through our system, and over 1.5 million news stories a day. And so how do we help them understand kind of those tools?
What is happening is the variety of data types that we have to deal with. It's not just a transactional workload, analytical workload, streaming, and especially some of the new machine learning and other applications that are emerging has unique and new different characteristics. Because you've got all the other attributes, why do we want to have disk at all? I don't want to have hard disk get to flash.
I think one of the key things that Flash has done is being able to kind of provide that consistency in the data retrieval, and so that way we know, when we're delivering information to a customer, that they'll be able to get it within an expected SLA. One of the great trends that we're seeing in the data center around Flash is the introduction of NVMe, and we really think that is going to be the next step in kind of improving the latency characteristics of Flash storage in the data centers.
Other attributes related to Flash is we look at not only from a performance standpoint, we look at the availability metrics we can do, because we not only want to do backups faster, we want to recover faster, because when you have an in-memory database with a huge footprint, recovery is very important. How do you do very fast recovery, which means you need to read a lot of the data that is backed up very fast.
We're able to take kind of this low latency, kind of high performance storage and be able to leverage techniques like machine learning and be able to kind of look at all the data as it passes through and be able to apply models to it to kind of say whether the market is relevant to our customers and be able to present that to them, and hopefully they can take action on it. We handle a whole bunch of news information, and we have over 500 news stories a second that come in, and with using flash storage, we're now able to deliver them to our customers in under 100 milliseconds.
All right, so I'm going to do my best to tie the story I want to tell next to BJ Miller, okay? And I'm doing this on the fly, so I hope it works. We are headed to a world that is radically different. Everybody knows that. I'm not telling anybody in this room something you don't already know. It is the magnitude of the change that we will see between now and the year 2025 is absolutely stunning. So imagine, if you will, an elite athlete like BJ walking into her home at night, and the house speaking to her saying, well, you look like you might be a little overtrained. I can tell that you're not only dehydrated, but you're a little low on carbs today. You should do this for dinner. In fact, the house may not even tell her that. It might already start preparing the meal for her before she even gets to a point where she can come in and change clothes and get relaxed and turn on the TV. We're headed to a world where this thing that we call IoT and a data-driven society is literally going to be able to measure our hydration levels, our health levels in ways we haven't even thought of. Last night, somebody pointed out that I was wearing 2 watches, and they said, why do you wear 2 watches? Well, duh, this one tells time, and this one tells me how well I'm sleeping at night, how many calories I burned. There's a watch guy right there. How many steps I took. So this is just the beginning. We haven't even scratched the surface, and the implications for this kind of world are absolutely dramatic, especially for all the IT professionals in this room and companies like Nth Generation that help put these solutions together and integrate them so that they actually work. So let me just, if I can, in the next 20 minutes or so, I want to first start just talking about kind of the macro data trends. I'm sure you've seen these numbers. Everything I quote to you in the next 5 or 6 slides are coming from IDC, so I want to make sure they get due credit for this information. And just kind of quickly click through this. Again, I know a lot of this is not new, but every time I look at it, my jaw drops when I think about the implications for all the things that we do as IT professionals. So a quick walk through memory lane. Before 1980, it was all about the mainframe. Compute and storage was all centralized in a single data center. We accessed that data through very, very dumb terminals. And then long about 1980, 81, 82, the first commercially viable symmetrical multiprocessing machines became available, and that was the beginning of open systems and distributed computing. Guys like Casey Powell at Sequent and Scott McNeely at Sun Microsystems were able to come up with some pretty innovative stuff, basically stringing together merchant microprocessors, giving you the power of a mainframe at 1/10 the cost. That was revolutionary, and this story was written about that, right? So there was a massive explosion of companies building ERP systems. In fact, I was involved personally, just remembering back this morning, in 1995, there was a pulp and paper products company called Weyerhaeuser up in Seattle that had a door division in Marshfield, Wisconsin. The door division itself was more than 100 years old. They were still building. They had majority market share. These are not doors that you have in your house. They're doors that they call them architectural doors. They put them in hotels and hospital rooms and commercial buildings. The fire codes alone and the complexities behind that were more complex than a Boeing 747, and we know that because the Trilogy configurator that was used to build 747s was also the same sales rep on these architectural doors, and he was blown away that a door could be more complex than a 747. True story. So we saw these companies coming out of the dark ages, building doors just using paper into a full-blown sort of electronic world, a massive step. And then we enter into the 2000s where the data centers expand and the cloud infrastructures, compute continues to be distributed, but the data starts to get centralized again. And this is what we're about to see, and it's going to get very, very interesting. So here's what the growth looks like. Here we are in 2017. We really haven't even begun to scratch the surface. We don't even know what this wave portends, what it means for us. So many people are still trying to figure it out. Let me just give you some of the math on just the NAND and DRAM manufacturers on the planet. There's very few of us, and there's a reason why. The barriers to entry into actually making volatile and non-volatile memory is incredibly expensive. It takes about $7 billion in 5 years to build a fab. That's why you don't see too many of us out there. Depending on how you measure it, there's about 5 makers of NAND fabricators on the planet. There's 3 makers of DRAM fabricators on the planet, and there's only 2 that do both volatile and non-volatile memory under one roof, and that's Samsung and Micron. And there's only 1 that does it in the Western Hemisphere. And the reason why I mention that is because I know there's somewhat of a security element to this nth symposium this year. And security takes many forms. It's not just at the software layer. We would argue it's also in the silicon. And if you're not looking at that as well, then you're leaving a big wide open door for just about any hacker in the world. And we'll talk a little bit about that at the very end of my presentation today. But then there's also this thing called a secure supply chain. How many makers of volatile and non-volatile memory, NAND and DRAM, are there that can guarantee a secure supply chain? We're the only one that has fabs in North America. We have one in Boise, one in Lehigh, Utah, and the other one in Manassas, Virginia, about 30 minutes from downtown DC. It doesn't get any more secure and solid than those 3 places, I think. So we feel very, very good about our ability to produce a product that we can be confidently aware of its kind of who the handlers have been and who's had access to that material before it gets to the end solution, which is held by the folks at Nth Generation and HP and putting them into servers that solve really demanding workloads. Now, what I want to do, without it sounding too self-serving, so please don't take it this way, the next click is going to show the Micron stock price. Like I said, it's just an interesting data point. I'm not promoting the stock. I'm not doing anything. But I knew it would go over just like horrible. I'm doing my best here. It is interesting, though. So look at this. So from 2010 to 2017, the market forecasters, again, in what is a very finite market, planet Earth can only produce a very finite amount of volatile and non-volatile memory. There's only so much that can be made every single quarter. And so some of you have dealt with some of the supply constraints. Well, let me tell you, it is real. I sit in front of the biggest buyers of this stuff on the planet. I'm talking about the heads of procurement for Google, Amazon, Microsoft, Facebook, Apple, Baidu, Alibaba, Tencent, the 8 biggest hyperscale companies on the planet. I'm afforded the opportunity to visit with them every week and compare them side by side. And I will tell you, the supply constraints are real. But it's not like we can just build a fab and stamp one out overnight. Even with the IP that we have, it takes time to do that and a lot of capital. So it's a very, very tricky, delicate balance that we walk. But the prognosticators saw, look, everybody knows this wave is coming. That is no secret. So for a minute they thought, well, this is one of those stocks that's going to benefit from that. Then of course it comes crashing down. Everybody here is also probably somewhat familiar with the cyclicality of of the semiconductor business. Well, we're a part of that, and we know that. But it is interesting to me the way that this next, kind of other side of the cycle is going up. We know it's not going to last forever, but I don't know where the stock price goes. I just think with what I'm about to tell you, this is going to make a little more sense, so just bear with me. Okay, so where is the data created? You got the core, the edge, and the endpoint. The core is the data centers that we all kind of grew up building, those on-prem architectures. And then the edge are those satellite data centers. Sometimes we build data centers out in the field to get, it might be due to data legality. The data can't cross borders. It could be a host of reasons why we put satellite data centers out, get the data closer to the people. But then the endpoint is all the laptops, all the mobile phones, all the watches, all that IoT that's going to happen, and it's going to continue to grow. It's interesting to me that those three kind of remain flat over time. In fact, core even starts to grow bigger in 2025. So to me, that's an interesting dynamic. You look at where the data is stored down here in 2017. There's some pretty serious growth in the enterprise, which also is interesting to me. Yes, mobile, you'll see cell phones with some pretty serious storage, especially with new forms of memory like 3D XPoint, where we're going to be able to put a lot of very dense storage in very small devices. But that's the explosion of that IoT thing that's about to hit us. In fact, let me click through another couple of slides. Data criticality, this is another one that's very, very interesting to me. When we talk about data criticality, this means that airplanes cannot land unless the machine-to-machine communication is happening. Or it could be one of us on an operating room table with our chest cavity wide open, and the surgeon is working alongside a robot, working off an Oracle database. They're taking and making decisions on the fly based on the inputs that they're getting at that moment, and making real-time decisions. Is that hypercritical? It's my chest that's opened up. Yeah, I would call that hypercritical. So the growth of that is amazing to me. And do you think that's going to be stored on a mechanical device with an actuator arm? Man, if it's my chest that's open up, I hope not. I hope it's on a piece of solid state with no moving parts. It's quicker, it's faster, it's more efficient. But the CAGR on that, 54% growth of hypercritical data between now and 2025. This tells us a lot about where our business is going and sort of the demands and the things that we're going to need, not only at the end user companies, but what the nth generations of the world are going to have to do as we continue to change and evolve. And let me just say one thing. I meant to say this at the beginning. I've never worked in the channel at a VAR or a reseller or a systems integrator. I've always been either with a manufacturer or an OEM and selling back to Rich. And he's been very gentle and kind to me over the years, and Dan Molina. I will tell you, there are companies in their space that have come and gone. They are here every single year, and there's a reason for that. I call them the world's best boutique systems integrator. And the word boutique isn't meant to suggest that they're small. It's that they have a high touch. And the reason why they're able to have that high touch is because they have quality engineering resources on hand that know how to go and do this stuff. I'm telling you, I'm not easily impressed. I run around this world and I meet with all sorts of Rich Baldwins out there. Very few companies have the staying power that nth generation has to be able to put these solutions together. And what amazes me is even as different as this world is about to get, the Rich Baldwin and his team know how to adapt, and we know that we can count on them to as a partnership with HP to continue to deliver solutions that handle these vaccine workloads. Another data point, the number of interactions per capita per day. Right now, we're between 200 and 300 times a day. We look at our iPhones, and now your wearable devices. That's going to explode. And again, it's going to be things that you won't even you won't even be aware or cognizant of the fact that your house is measuring your own body humidity, your own body hydration, or maybe your electrolytes are off, or you've taken in too few carbs or too many carbs that day, and your house will know that. That is the Internet of Things, and that's going to be 5,000 interactions per capita per day. That's where this world goes crazy, and the demands on the data centers behind it, whether it's cloud, on-prem, off-prem, hybrid cloud, doesn't matter. That stuff's going to have to be stored in the optimal way so this whole thing works together. But it is amazing when you look at the growth of that. Another interesting data point, we hear so much about mobile data, and yes, it is going to grow, we know that. But look at how it basically remains flat as a total percent of the global data sphere. Okay, so you would think with that kind of growth, it's also going to be a bigger percentage of the total global data sphere. What this chart is telling us is that the rest of the global data sphere is going to be growing just as much, keeping the mobile percentage basically flat over the next 8 years. Another view of the data, the real-time nature of the data. Okay, this, again, hypercriticality, it's all going to be real time. That is an even steeper growth curve than the mobile data, and yes, the percentage of the data sphere actually increases with it. That's going to be one of the bigger parts of this. So just be thinking about the real-time nature of this. Again, does a mechanical device with an actuator arm really lend itself well to something that's got to be hypercritical and is real-time? Probably not, especially in a multi-tenant architecture. It's really hard to guarantee quality of service when you have thousands, if not tens of thousands of people hitting the same data all at the same time. So IoT drives real-time data. We know this is coming. The whole world's going to get real interesting. It's going to be fun to watch this. I can't wait to see what they do. I'm an athlete. I still try to think I'm 25. I have a 22-year-old son who just is a pro mountain bike racer, and I was racing against him a few weeks ago and trying to keep up with him, and I crashed and broke 4 ribs. So if I say anything completely stupid, it's the Percocet. It is not me, I promise you. Okay, by storage type. So again, you know, no secret there. We know this is coming. But just appreciate the fact that if you're the CEO of one of these fabricators, these NAND or DRAM fabricators, the delicate balance that they have to manage as we go through having too much supply, not enough supply, $7 billion investment. Do you place that bet now? And if so, what are the average selling prices going to be 5 years from now? I don't know how they do it. In fact, I met with our new CEO yesterday, a gentleman by the name of Sanjay. He was one of the founders of SanDisk. He's now our new CEO. He's been in the job about 5 or 6 months. I don't know how they capitalize these companies. It is a polynomial equation of the highest order, and it takes extreme knowledge and a really, I guess, some intestinal fortitude is what I will say to be able to sleep at night knowing that they got to manage to this growth and not get too far out over the ski tips and completely crash and burn the company. It is a delicate balance. So, all right, that's the look at all the kind of the market data. Just wanted to set the stage with that, and now I'm going to talk a little bit more about the solutions coming from Micron that are working in conjunction with Hewlett-Packard and Nth Generation to meet some of the demands of what we know is coming our way and some of these really exciting opportunities. The world created 16.3 zettabytes worth of data in 2016. And by the year 2025, as that graph showed, we'll be an order of magnitude bigger than that, again, for all the reasons that I just mentioned. So it's going to happen. The velocity and the pace at which this is happening is going to continue to accelerate. If you can actually believe that, I don't even know how that's possible because it already seems like it happens so fast right now. And then the nature of the data, going from structured to unstructured, that's going to be the really bigger challenge, I think, in managing these big data architectures and doing it in real time. It's just the challenges. As IT professionals, I don't know how you all do it. You're burdened with the pressures of getting more out of your data center, increasing performance, and cutting IT budgets all at the same time. That almost seems completely unfair, but yet somehow every year we manage through it and we figure out ways to get it done. So, Micron and what we do with NAND and DRAM it really does touch many different parts of the system architecture of the data center, and a lot of times people don't realize that. In fact, I was on a sales call not too long ago, meeting with a very large company, and they wanted to know why it was we were meeting with Micron. And this was a guy who's been in the industry 40 years, and he just knew us. Our brand is, we're just a DRAM company out of Boise, Idaho. We make some commodity product. One of my jobs and one of my missions as the VP of Worldwide Enterprise Sales is to make sure people understand we're a lot more than that. And oh, by the way, I'll show you a slide here in a second. Some of the analysts in the market today really believe that things like artificial intelligence are going to decommoditize something as commodity as DRAM. It stands in the critical path of these things happening. You will not have the artificial intelligence that you want, that house that's speaking to you, telling you you're too dehydrated, you're overtrained, and you need to get more sleep and hydrate more tonight. That can't happen without lots of DRAM. I'm sorry, it will not happen. And what's crazy is that there are so few actual manufacturers of it on planet Earth. There is a finite supply, and so we got to manage this explosion of demand and manage the supply to it. So let's go through each one of these. DRAM, it's volatile memory. Here's a chart that I like to look at. We've got an X and Y axis. Across the horizontal axis, we've got latency, and across the vertical axis is cost. And we are one of the makers. So they're in a joint venture between Micron and Intel. We created a new form of memory called 3D XPoint. Don't confuse that with 3D NAND. I'm not the marketing person who came up with the name. I never would have put the word 3D in. I would have just called it XPoint. Because there's 3D NAND is something completely different. So just try to separate those two for a second. I'll spend half my career explaining that for the rest of my life, unfortunately. And by the way, when I go around Lehigh, where the birthplace of 3D XPoint, and I ask who came up with this name, nobody wants to own up to it. So it fits right in between the most expensive and the fastest volatile memory and the slower but still pretty fast NAND flash. Okay, so if you can just picture in your mind, this is a chart that really helps to illustrate what that is. Yeah, it's going to be a little bit more expensive than NAND flash, but it is going to be faster. So basically, you're getting storage at memory speeds. And that's what we see the world clamoring for. It's going to allow the mobile handsets to do some things in applications that we haven't even considered yet. It is a very exciting new development. But like many other things, it'll take time to find its place in this world. And like I said, this is a joint venture between Micron and Intel. Literally 51-49%. We own 51% of that JV. Intel owns 49%. And here's that quote that I was just mentioning a minute ago. The folks from Credit Suisse really believe that just one example of a workload and the strains of that workload that is going to place on the underlying infrastructure in artificial intelligence is going to decommoditize memory and place it in the critical path of some of these things being developed. And this is going to happen no matter what. So we're excited about that. We think that's one of the drivers behind the stock price doing what it's doing right now. And it's not just our stock price. Everybody in the space is doing really well. Fast storage. So we just released our latest NVMe drive, the 9200. This is a 3D NAND-based product, super fast. And Micron is super excited about our abilities in 3D NAND. In fact, we have a fab in Singapore that until recently had about 250,000 square feet. And by the way, if you've never taken a tour of a NAND and DRAM fab, you should. You cannot appreciate doing what you do as IT professionals, and as much as you're going to need this stuff in where we're going and what the slides have just told us. It'd be nice to understand how this stuff, just see with your own eyes what it takes to build this stuff. When I walked into a fab for the first time, it was actually in Singapore, and they smock you up, you're in the bunny suit, it's a clean room, and for as far as the eye can see, football fields of robots that are building this stuff 24 hours a day, 7 days a week, 365 days a year, and every single robot costs somewhere between $8 and $10 million. So when I talk about a $7 billion investment, and so the complexities behind what it takes to take a piece of sand from the beach, turn it into a silicon, and then into a wafer, and then make it either volatile or non-volatile memory is just beyond comprehension, the complexity behind that. But it yields some pretty cool stuff and allows us to do some amazing things. NVMe, from a storage perspective, is going to take us yet again another leap forward in speed and performance and managing workloads. In fact, one of our customers, when he put it into his data center, he came back and said what I thought was the best thing ever. He said it was like aspirin for my data center. Everything just sort of felt better. The CPU utilization went through the roof. He was running an average of 2% utilization on his CPUs. He went way into the double digits, and he thought he'd died and gone to heaven. You know why? Because his Oracle database licenses, which are charged by cores, just went down significantly. So the amount of money he saved just on Oracle database licenses by using fewer cores, because he's getting more use out of the ones that he already owns, paid for the system that he just bought. Pretty interesting stuff when you see those new levels of efficiency coming through. Anyway, the current NVMe drive 9200 that we have is the fastest and the densest on the market today. We're very excited about it. It is literally just hitting the channels right now. It's getting into the distribution centers. It is available, so let us know if you want to have a look at one, and we'll see what we can do about getting you a sample. In fact, at our booth this week, stop by and see our friend Cece. Where are you, Cece? There she is right there. She will be there to talk to you about some of the giveaways that we're going to be doing, so please stop by and see my friend Christine. All right, so solid state builds apps that are more responsive. Again, just by comparison, with a 7.2K hard disk drive, sort of unfair. We probably should have put a 15K drive. Even I will admit that. I didn't build this slide. Then your standard SATA SSD, and by comparison, the new NVMe drive is 22 times lower, 500 microseconds in terms of response time. So very, very fast. It is a significant jump forward. See, I knew this was going to be tough, going from an Olympic athlete to talking about speeds and feeds. I'm so sorry. I'm doing my best. I wish I had a joke to tell once in a while. Primary storage. So Flash is chipping away at hard disk drives, and I believe it was last year that we crossed over that line from a cost and total cost of ownership between NAND and a 15K drive. This year we're going to cross that line with our 3D NAND and the advent of 3D and all of its beautiful offerings. We'll cross the line with 10K drives, and next year we'll see that go yet again across the 7,200 RPM drives. So it is chipping away at that. Now, are we predicting the demise of hard disk drives? Absolutely not. They are pervasive. They are everywhere. They are melting polar ice caps as we speak, but we love our flash media because of the power profile. They're cheaper to power, they're faster, and they reduce the footprint in your data center in a way that's pretty significant. Again, I'm not going to go into too much detail here, but there's several different ways to build three-dimensional NAND. And let me just say this. What Micron can do at 32 layers, nobody can do, none of our competitors can do at 64 layers. When we go to 64 layers, we will yet again distance ourselves from the competition. It's a more efficient, lower cost way of manufacturing. And so the guys that have been in this business for a very, very, very long time made exactly the right decisions and placed the right bets at the right time. They took that Singapore data center at 250,000 square feet and doubled the size to 520,000 square feet in the last couple of years, all in front and in expectation of the growth of three-dimensional based NAND. So we have the largest NAND fab on the planet that is producing 3D NAND and doing it with the very, very best cost profile and the best technology behind it. So we're very, very pleased with that. The software. So we're not just looking at the hardware. In fact, all the software that's out there was written for spinning media and all of its idiosyncrasies, the latencies and the actuator arms and just the way that the data is architected on a piece of spinning disk. We took a look at that and thought, wow, there's an enormous opportunity to improve things like garbage collection and write amplification. So you will see more advances from Micron from the software angle as we write software specifically for flash instead of for spinning media, and you'll see dramatic increases in performance. Endurance is going to improve dramatically. I know some of you have felt that. We've seen some of those drive writes per day and duty cycles that have worn the flash down in a way that was probably not ideal. That's going to improve dramatically. You'll see advances in that in a very significant way. That by itself is a major, major development. So the OpEx just continues to get better, and that's, as I mentioned a minute ago, as IT professionals, we are required to increase performance, lower costs, and reduce budgets every single year. It seems impossible, but yet somehow we do it, and it helps when advances like this come along. So I'm going to power through a couple of quick slides just to give you an idea. With the lower system write amplification, the standard Linux storage stack, 25 write amp factor. With a Micron optimized stack, that'll be down to a 3 write amp factor, greater than 8x improvement. And so more database operations per second. Who doesn't want that? Every company would love to have better performance there. Again, another at least 8x performance, and that's a very conservative estimate on that. The reduced latency and the quicker application response, 95% plus latency reduction. This is, so many times we hear people talking about IOPS and throughput, but what about latency? That's also another major factor in the overall performance picture inside of the data center, and we're going to see some major reductions there as well. Better power profile, just mentioned that a minute ago, 85% reduction. It's a significant leap forward, and it's needed. It very much is. There's so many cities right now where the amount of electricity a given data center is allowed to consume has been capped. They can't grow anymore. They have to put their data centers in other places. And we see major hyperscale companies putting data centers on polar ice caps in places where the air is cold year-round for obvious reasons. So it's a very interesting thing. Okay, moving right along. So the platform, maximizing the value for your investment. We have partnered, we've gotten busy in the ecosystem and have forged a couple of relationships. One of them, for example, with what we call Micron Accelerated Solutions. And one of them is with VMware in the vSAN area. We've been able to do some very unique things. We have some reference architectures that many customers are using today to build out their own software-defined storage data centers in conjunction with partners like Nth Generation to help make sure that, again, they increase the performance, increase the agility and the flexibility of their data center, and as they deliver a service level agreement to their customers in terms of response times, uptime, and we're very excited about the partnership not only with VMware but also with Ceph and Red Hat. So another just quick video there to talk about a really recent development, and that is, as I mentioned a minute ago, that one customer that stuck individual NVMe cards into his data center felt like Aspen. How about shared NVMe? How about having 24 of those in a server and a stack of those servers giving access to block-based storage to tens of thousands of users with phenomenal performance? And so this is where we're headed. We can't do this without partners like Nth Generation and Hewlett-Packard. Obviously, we don't make the servers, and we're not out integrating it. We leave that to the Rich Baldwins of the world to make sure that our customer has the high touch. But the kinds of change that something like this will bring about are very, very significant, very exciting. And I realize I'm just very, very lightly touching on these. We're whetting your appetite. We'd love to talk more about it, and we're happy to do that in conjunction with Nth at any point in time. But when we talk about Aspen for the data center and all the different things that we touch, that CPU utilization almost every single time goes up. And who doesn't want that? We have stranded CPU cycles because of the way the storage architecture sits today. You put a shared NVMe system in that data center and you will see dramatic changes. And like I said, oftentimes if they happen to be running an Oracle environment, just the savings on their usage, their efficient usage of the cores that they have today will pay for that system. Power gets better, everything just feels better. It's like Aspen.
There's an ancient proverb stating, if we only look at the path, we miss seeing the sky of opportunities. Well, the same goes for technology. There's a bigger, vaster, more holistic universe out there of potential, and today, all planets are aligned to maximize our data. But not just maximize it, actualize it. Transport data from simply being collected facts and figures into a more enlightened, transformative state. Deeper, useful, intentional information to guide business decisions and transform organizations. Micron is making that happen today by offering silicon to system solutions to solve problems and realize new opportunities across the globe. But what does that mean? Not just memory advancements, not just storage solutions, but a holistic business insight platform. Comprising memory, storage, software, and the system, building a data insight stack. An entire chain of throughput to push, pull, crunch, and enliven data to enlighten and embolden your business options from one application to another. We're connecting layers of technology with business intelligence, analytics, connected tech, and more for amazing results. It's the difference between following a recipe and creating your own eclectic menu. Micron helps you define what amazing looks like for your business demands, way ahead of existing intelligence trends. From silicon to system, Micron is taking data to an enlightened state and elevating it into actionable intelligence to help you, your organization, and your customers realize the sky of opportunities. You and Micron. It all stacks up.
So I will wrap up with this. We want to make sure, if anybody, when you leave today, if you remember one thing from my sad position behind BJ Miller, an Olympic gold medalist, is that Micron is not just a DRAM company. We are full silicon to systems. And in fact, I like to say we take sand to silicon to systems because we really do take maybe the most commodity thing on the planet, which is sand at the beach, and turn it into something completely phenomenal. We're excited about the future prospects this has to offer, but all of this wouldn't matter unless all of this is secured. So I do have one more slide just to talk about data security. We haven't forgotten about this at Micron. In fact, we have a number of industry firsts, where Micron was the first in the market with an encrypted SATA SSD, and the first company on the planet to qual that drive was HP, because they get it. They understand the security requirements, and they're hugely important. We're on our second generation of TCG SSDs on what is our 5100S SATA drive, and we're on our 5th overall generation on self-encrypting drives. So we've looked at data at rest, data in flight. We know the challenges there. So many times this is forgotten about, and believe me, the hackers out there, the guys that want to do damage, one of the first places they will look is at the volatile and non-volatile memory, and if those doors are not shut down, they will use that to get in. So we've got that bolted down. We've had a number of conversations with the federal government about this topic, and it's one of the things that we do in our Manassas, Virginia facility is look at the security challenges that we have out there. And so we're excited about these things. We know that Nth Generation has a practice around security. It's another reason why we really value that partnership. Because at the end of the day, it takes somebody to bolt it all together and pull it in. So thank you for your time. I hope you weren't bored. And Rich, thank you for the opportunity.